So friends, in the previous lecture we had come across the different concepts regarding the camber and stopping side distances. So now we are going to solve some of the numericals based on this camber and stopping side distances. So if you had not subscribed to my channel, please subscribe. So in this question, in a district road where the rainfall is heavy, a major district road of waterborne macadam pavement 3.8 meter wide and a state highway of bituminous concrete pavement 7.0 meters wide are to be constructed. Determine the height of crown with respect to the edges in these two cases. Now let's draw a rough sketch. In the previous lecture we had come across what is this camber. This is our roadway. Along the longitudinal center of the roadway, okay, this is the top view plan of the roadway for a road stretch. This is the longitudinal center, which you can see it here. This raised portion we call it as a camber. So it has to be evaluated with respect to half of the total width. If total width is W, we have to consider W by 2. So based on different road conditions and the intensity of the rainfall, the percentage of the camber with respect to the width has been specified. So let's write down the given parameters. So there are two different cases. First one being for the major district road, which we can call as MDR, for which the width has been specified as 3.8 meters. The intensity of the rainfall they have specified in both the cases as heavy. Now for the heavy rainfall, and the first one was the waterborne macadam, for which the camber value has been specified to be as 3% of the width of the roadway. So the crown height becomes camber value multiplied by width of the pavement divided by 2. The camber value is 3%. The width of the pavement is 3.8. Half of it has to be considered because I have specified here earlier. It is along the center of the total width. So this will become 0.057 meters. So this is the answer for case 1. Now for the second case, they have specified about bituminous concrete pavement and the rainfall is heavy and the width is 7 meters. So let's solve that. Now for the heavy rainfall and this type of pavement, the camber value has been specified to be as 2% of half of the width. Okay, so the crown height will be equals to 2% multiplied by width. The width in this case, it is a state highway. It was specified as 7.0 meters. So it has to be 7.0 divided by 2. This will give us a value of 0.07 meters. So this is the answer in the case 2. Now next we shall move towards another problem. So calculate the safe overtaking side distance for a design speed of 96 kilometers per hour. So these kind of questions can be found from the Khanna textbooks of highway engineering. Alright, now let's solve this problem. See, there are no data have been specified here, so we have to assume the required data to evaluate the overtaking side distance. Now overtaking side distance is d1 plus d2 plus d3. Now what are d1, d2 and d3? You have to see the previous lecture to know in detail. I will just write down the formula directly here. Okay, d1 is nothing but 0.278 times of Vb times of Tr. This is our reaction time. And next comes our d2, which is 0.278 Vb times of T, capital T, half of At square. Next comes the value of d3, which is Vc times of capital T. So this Vc is nothing but 96 kilometers per hour, and you have to multiply this by 0.278. 0.278 I have specified here because this is used to convert kilometers per hour to meters per second. Now the data that we require here is the Vb and A. So this Vb has been specified as speed of the fast moving vehicle Vc minus of 16 kilometers, because while overtaking it has been assumed that The vehicle which is not actually traveling at a design speed shall travel at 16 km lesser than that of the design speed, then if that vehicle can be overtaken. So these are standard specifications one needs to remember. So this will be 96 minus of 16 is equals to 80 kilometers per hour. Now our speed moving vehicle at 96 kilometers per hour has to overtake this VB moving at 80 kilometers per hour. And while overtaking, the vehicle obviously needs to accelerate. Now that acceleration has been specified as 2.5 kilometers per hour per second. Okay, now let's convert this into meters per second square. So this shall be just multiplied this by 5 by 18. Suppose if it is in meters per second square, if you have to convert it into kilometers per hour per second, then you have to do the reciprocal of this one as 18 by 5. So this will be equals to 0.694 meter per second square. Now the reaction time as specified from Indian Road Congress is 2 seconds. Okay, so we have found out VBA and T has to be found out here. So this value of T, which is given as 4s times of 4s divided by A. Now this S value is nothing but the distance between the two vehicles, one which is overtaking, the one which has been overtaken. So that S is equals to given as 0.2 times of VB plus 6. Okay, this 6 meter corresponds to the base length of the vehicle. Okay, so this is equals to 22 meters. Substitute here the 80. So the TS in this place becomes 4 times of 22 divided by A. The value of A is 0.694. So this will give us the value in seconds. So T will be equals to 11.3 seconds. Now we'll write all of these values on one side and evaluate overtaking side distance. See, this overtaking side distance, whatever I have provided here, this is for two-way traffic, and in case of one-way traffic it is equals to d1 plus d2, because in the one-way traffic there will be no vehicle approaching in the opposite side, so d3 will be eliminated. So now let us substitute these values in this equation here which is specified above. So VB is 80, the reaction time is 2.0, again VB is 80, the reaction, this is capital T, the time required for overtaking. Okay, so this is 0.694 which is our A, and T square here, and value of VC, which is the speed of our fast moving vehicle which has to overtake the slow moving vehicle. So this will give us a value of, so our D1 here is 44.8, D2 is 295.62, D3 is 301.57. So summing up all these, we will get the value of 645.5 meters for two-way traffic. Suppose if you have to consider it for one-way traffic, then you have to ignore this 301.57 and keep sum of these two. Okay, however they have not specified it either it is for two-way or three-way, so let us keep it to be assumed as it's a three-way flow of traffic. Next we shall move with another problem. Now in this problem, for a vehicle traveling in a descending gradient of 2%, determine its stopping side distance if it's traveling at a speed of 80 km per hour. Now first thing, we have to determine the stopping side distance, for which the formula has been provided as 0.278 times of speed of the vehicle multiplied by the reaction time plus 0.278 multiplied by the speed of the vehicle whole square divided by 2g f plus or minus n percent. See, this n here represents the gradient effect. So this f here is nothing but the coefficient of longitudinal friction, which can be taken as 0.35. Actually the value of the friction factor is 0.7, but due to the braking efficiency is only 50%, so it becomes 0.35. Coefficient of friction shall be taken as 0.35. Now the reaction time here in this case, earlier in overtaking side distance I had considered it as 2 seconds. In this case it shall be 2.5 seconds as per IRC itself. Okay, so just we need to substitute the values here. And one more thing is, the gradient is descending in nature, so it is negative. Gradient is descending means this is a vehicle moving here. So what happens, this gradient, when it moves in the downward direction, it favors the movement of the vehicle. That is, it favors the speed of the vehicle. The speed of the vehicle can increase here. That's why the n is negative. If it is negative, then the numerator is obviously a higher value. So the stopping side distance obviously required is higher, because there is higher velocity of the vehicle. To stop that moving vehicle, which is moving at a higher velocity, the distance required to stop it is always higher. Okay, because the gradient effect adds up here. Now we shall just substitute the values here. We know that the speed of v is given as 80 kilometers per hour. Substitute the values here. So this is n value here at this point. Okay, so this will give us a value of 131.69 meters, which is approximated to 132 meters. Okay, so this is the stopping side distances. Next we shall move with another problem. The driver of a vehicle traveling up a gradient of speed 60 kilometers per hour requires 9 meters less to stop after he applies brakes, as compared to a driver traveling at the same speed down the gradient. Determine the gradient value. Here another parameter has been given as the coefficient of longitudinal friction. In this case has been given as 0.40. Now let's understand this question here. This shall be our gradient, okay, which is at some angle theta. Now this be a vehicle traveling up the gradient, and this be a vehicle traveling down the gradient. Okay, represented by an arrow like this. Both are speeding at the same value of 60 kilometers per hour. Now the vehicle traveling up the gradient requires 9 meters less than the vehicle traveling down the gradient, which is nothing but number 2. So SSD of this vehicle is plus 9 meters, which is traveling down the gradient, and this one requires 9 meters less. Let's keep this the stopping side distance of this vehicle as SSD, or simply represent it as S. Okay, so both are traveling at the same speed itself. Okay, that's one thing we have in common here. Stopping side distance of the vehicle 1 and 2 here. Vehicle 1 requires 9 meters less than that of the vehicle 2. Pardon, here this is minus here. Okay, so S1 will be equals to S2 minus of 9 meters. What we need to determine here is the gradient value and substitute the values for stopping side distances formula. That is nothing but speed times of its reaction time. I am writing it here for S1. Okay, and then we have V square by 2gf. And this is the value of S1, which is actually traveling up the gradient. So when it is traveling up the gradient actually opposes the power of the vehicle, so that the speed is reduced, and the stopping side distances hence required for the vehicle traveling up the gradient is lower than that of the vehicle traveling down the gradient. This is equals to S2 is nothing but this plus becomes here minus here. Rest of the values remains to be the same. As you can see here, I have specified all the values. The common terms on both the ends strike out. Pardon, this is minus of 9 meters. Okay. So substitute the value for V here, which is 60 kilometers per hour, and the value of F here 0.4. The gravity 9.81 meters per second square. The same values shall be substituted on the RHS side, and N shall be found out from both the sides. Okay, simplify this. We will get the value of N as 0.05, or this can be written as 1 divided by 0.05 is equals to, and 1 divided by 0.05 is nothing but 20, which is nothing but 1 in 20. You can call it as the gradient value. Alright, so this is just a common simplification here, because if you simplify this back again, this will go up, okay, as 0.05 itself. 1 in 20 gives you 0.05 itself. So with this we finish some of the problems based on the concepts that had been explained in the previous video. So sorry I had delayed too much. There was too much of gap in providing the next video. So I shall be updated regularly from now on. So there will be more videos coming from civil engineering end, from this civil ed. Thank you for watching. Kindly subscribe.